Hello friends, welcome to this session of Learning R. And in this session, we are going to see the complete workflow of data analysis for research data. And for that, I will start my RStudio. In that search, I have typed RStudio. I have clicked the name of that app. RStudio is opening. And when it opens, I will start with new file, new file, R script. And there I will set my working directory, and in that I will go for this one. I will go to Windows, and here in RWorks I will create a new working directory folder, my demo or programming this is, and I will open that. I will go to path to copy that path and bring that to my R session, and here in this inverted quote I will paste that. I will convert this forward slashes, backslashes to double slashes so that R will recognize that. And you can see here my working directory is not this. I will run this line just by doing this, and you can see here that line is sent to console, evaluated, and working directory has been set. Okay. This is the first step to set your working directory. Now I will put my data file. I will search my data file here, and my data files I usually keep in RWorks Studio only, and will transfer that file. This is resin data set, and I will copy that and will transfer that to my working directory, that is my demo R programming, and here I will paste that. Now I will go here and I will type list.files command so that I will get the file names here in console, and I can copy that to avoid the typing mistake. Control enter is the shortcut to run this. Your cursor shall be on that line and run that, and this is the data frame. Now this XLSX is there, therefore I have to call a library, and that is read Excel library. If you have not installed that read Excel library, you have to go to tools and install packages, and there in that dialog box will open. You have to type in read Excel and click here, click install, library will get installed, and after that type this code and run that by pressing Control enter. Library read Excel is there. Now I will bring my data into a object called as data frame df. That assignment operator, this is assignment operator, and for that assignment operator I am using the shortcut that is alt plus that minus symbol. Now you will get this by pressing this alt plus minus. You have to keep pressing alt and then press minus. You will get that, and here I will use the function read underscore XLSX. This is my file type, and there I will go for this file name. I'll copy the file name and will put that, and please remember that file name shall be in inverted quotes, and when we run that our data gets imported. I will see the data by looking at the structure df, and these numeric data say vectors are there. Area 8 vectors are there. Out of that 7 vectors are numeric vectors, and 1 vector class is character vector. And that summary also I can see, summary df, and that summary shows me the summary area. Mean area is 87,804, that may be in pixels. Major axis length is 430.9, minor axis length is 244.5. These are all parameters showing the structure of resins, different resins. And the class vector, there are 2 classes actually. Here one class is Kesimen and other class is Bensington. We'll see that class also, how many classes are there and how many observations belong to those classes. Here total 900 observations are there, and we'll see that df dollar to say that we are asking for that vector belonging to that data frame df. df class, and when we run that, we can see here that Besni are 450 and Kesimen are 450. Now we'll see the distribution of the different variables, the distribution of area, distribution of measure length, minor length, like that. And for that we'll plot a box plot. Plot density I will ask it to compute, and this density will be plotted, and that density will be df scalar, and any of the numeric we will go for that and run that. And you can see here that it's not normally distributed. A symmetric distribution we are not seeing here. The mean will be somewhere here and median will be a little different, and it's a skewed plot, not normal distributed plot. We can have box plot also. I will go for the box plot, and these are very simple intuitive codes to get the plot. And the variable I will go for there, that is df dollar area. We'll run that, and you can see here that some outliers are there. Okay, box plot is the 5-point summary. This is actually median, and you can see that median is not symmetric, is not at the exact mean value, exact center. Yeah. Some observations are there towards, more observations are there towards higher side. Yeah. Now box plot, many other plots are possible in this. Just to know more about that, I will go for a library called as ggli. This library provides us a very beautiful function to see pairwise distribution of these variables. Much exploration on the data can be done by using that plot, ggpairs plot. And that ggpairs, I will go for the df. Entire data frame will provide as, and a large plot panel will be produced, and this large plot panel production is going on. And at the end we'll see the entire plot panel here. It's plotting it, and just because of my RAM limitations and that, it's taking some time. Now these are the correlations of those variables. This is correlation of major axis length with area. This is correlation of minor axis length with area, and you can see good degree of correlation is there with the area. Convex area is also highly correlated with this, and perimeter is also highly correlated with this. Okay, multi-way correlations are there, and these densities are also, you can see that not all variables are normally distributed, but correlations are, good correlations are there. You can see good correlations. This data can be used for classification models, because those for classification models we have to explore whether this is what is the distribution between those different classes. AES will go for color is equal to, and for that df dollar class I will go for. These two classes will be shown differently. Again, it will have to compute a lot at the back end to get all those different plots: density plot, scatter plot, box plot, histogram. If no character variable is there, it goes for bar plot also. And you can see those different variables getting differently separated out. And different correlations are also there. Overall correlation of Besni, correlation of specimen, minor axis length, major axis length. All this data is suitable for classification models. For linear regression models also this data is suitable, and this data is suitable for t-test also, because large data values are there, exactly same observations are, similar number of observations are there. Therefore we'll go for t-test, and for that t-test we will use the formula interface that area is determined by this tilde symbol is for determination, and you will get this tilde symbol above the tab button and below the escape key on your keyboard, and that I will go for class. I don't know whether these names are correct. Area and class, yeah, and all this data belongs to data frame df, and I will not go for other variations of t-test, and will run that. and here you can see the t-test. T value is 24.038, quite larger than 2. Therefore, we can say that our variables, the area of different classes differ significantly. That p value is also very small, negligibly small p value, and the confidence interval is also, the zero is not there between these two confidence interval. This confidence interval are more towards the positive side. Therefore, we can say that area of the class Besney is way more as compared to that of Kasiman. You can see that here. Mean of Besney is 1,12,000 and Kasiman is 63,000. Almost twice the area is there for Besney. Besney is quite large as compared to that. And this, you can visualize this report also. I will save this as model. T-test mod, I will give the name, and we will run that. That will get saved in the memory, and I will call for a library report, and this report will provide me a quite good report. It is saying that is not there, library report is not there. Therefore, I will go to tools, install packages, and I will go for the library report and install. And as the library installs, installation is quite faster. It installs all its dependencies together also. It will not take much time. And it says that failed to lock directory this one, and I have to remove that, try removing this lock. I will just copy this. This is troubleshooting. I'll copy the error. I'll go there in Explorer. I'll paste that and I will run that. Okay. Here, that lock directory shall open, and I think this is lock directory, and I will have to delete that directory. Therefore, I will go one level back. I will remove that lock, and I will locate that lock here. 00 lock is there. I will delete that. Okay. That lock directory has been deleted. I will repeat the command again. Install packages report, and we'll see whether it gets installed or not. It is getting installed properly. Yeah, it got installed. Now I will call library report, and for that I will use the function report to see the t.test for these two classes. T-test model is there. The name is different. T-test dmod object is there. I will run that. It says that it's not there. Spelling mistake is there. Therefore, I will copy this name and use that here, run that, and we'll see the report. A quite good text report is there. Effect sizes were labeled following Cohen's recommendations, Wells to sample t-test, and all that explanation is there. You can paste that explanation in AI to understand it more. I'll show you usage of another package also, that is called as library Weber. As you practice, you will remember all these. It's also called library Weber is not installed. I will go to tools, install Weber. Many tools are available. It's a free. All are free to use, and all these dependencies will get installed. Installation is going on. It will take little time based on my net connection and my processor efficiency, but it will install. And as once you install it, you don't have to keep on installing it again and again. All the dependencies are getting installed. Installation is complete, and now I will plot the object here, t-test mod object, to show you where that t value lies. Okay, I have to call this library first. I will call the library and then only this plot will be activated, and now the plotting is going on, and you can see here this is the rejection region and this is the acceptance region. If our t value, which is here, lies here, I would have to accept the null hypothesis that there is no difference between area of Besney and Kensington. But here the t value is quite away towards much larger side, and we have to say that there is difference between the area of these two classes. That's how we test the hypothesis. We'll here fit the model also, linear model, to two variables, area and will not go for classification model will go for that, but here we'll go for the linear model LM, and area determined by some other one. I'll have to see some other variable, measure axis length. I'll have to copy the name. I'll see that in my console. Here that measure axis length is there. Okay. We can see the correlation also between these two. First, if those are highly correlated, then only we can use those for analysis. Area and df scalar measure axis length, and run that. Its correlation is 0.9327. Very high degree of correlation is there. We can use the core test also for that, core dot test. Again the same one will provide to see whether we get that p value, and all those informations will get by core test here. Okay. And all this you will understand as you go on exploring the statistics further. It's not difficult at all. I'm again and again repeating that. And here the model is there, LM in bracket area determined by measure axis length, and this is actually formula interface for the model. And here the data is coming from DF, and I will run that. And here mod has been computed back, and I can see the quality of that model, or I can see the summary of the model, and will run that summary of the model. You can see the summary that we can get the equation of the models also, the residuals of the model. We have the intercept, we have the measure axis length, these are the coefficients, this is standard error of the coefficients, this is the value by which we can assess whether the correlations are significant or not. P value is very small, therefore we have to say that correlation coefficients are significant, and adjusted R square value is 86.99. 0.8699. We can say that 86.99% of the variation in area is explained by that measure axis length. And if you want to see quality of the model, whether that model has got fitted properly or not, you can plot the different diagnostic plots using just the plot function. You can apply here that we have plotted the density plot using the plot only. You have plotted the box plot using the box plot function, and here we have plotted the t-test model using that plot, and here we are plotting the regression model here. And you can see here the residuals, how those are against the fitted one, not exactly horizontal line. Therefore, some issue is there with this model. Another plot we'll see. Here I have to keep enter that not normally distributed. We said that data is not normally distributed, therefore a little violation of assumption is there, and our results are 86% accurate. It will be again that social all those diagnostic plots are there. Here the will require more time to understand that some values are there which are actually influencing the outcome. These are outlier values, and these are influencing the outcome. And that's how we can analyze the data. We can understand the relationship between different variables. We have explored just few variables here. We can keep on exploring all those variables very easily using the R programming. And it's very easy nowadays to understand this. You just have to copy the output and put that output to your AI of your choice. And here I will go for Cloud A or ChatGPT. DeepSeek also I can use, and I will put that, paste that in the prompt and run that. You will get all the information about the model. that equation has been provided, coefficients have been provided, statistical significance, model fit, and all that is there. I can ask it to give me materials and method section for this analysis, and it will provide you. I'm not data collection and all that is provided. Little issue is there with this 899 version, R version, and all that. You have to mention that there. You can ask it to make it in paragraph wise or something like that. That's all. That's how we can use R programming for data analysis, and it's a very good tool, the best tool for research students, best skill to be learned by research students. And thanks for watching this video. If you have liked this video, please click the like button, and please subscribe to my channel if you have not subscribed yet. Thanks again for watching.